Hello everybody. In this video we're going to talk about creating functions in Python. So as you know, in general there are two types of functions. Some of them return something and some of them don't, right? And in C we show like int or float or whatever the type of the output variable is before the name of the function. And if it didn't return anything, we showed void. In here, we don't need to. All we need to start a function is using def to define a function, give the name of the function, and then inside the parentheses, provide the input arguments. No variable type is needed, as we know for Python. And then at the end of the code, if it's returning something, we say return and then provide all of the outputs separated by a comma. We do not need to put them in any parentheses, brackets, or anything. And if it doesn't return anything, then just finish the function, as simple as that. So it's very easy to create a function in Python. And here I'm going to show you several examples. So here, let's say I have a function that converts my Cartesian values to polar coordinates. And I pass to it x and y, and it gives me r and theta. And here, just for the sake of demonstration, I added a third parameter, which is a coefficient. And this coefficient, I give it a value. So instead of waiting for the user to give me a number, I set up a number for it already. So if such a thing happens, then when I call this function down here, I do not need to say and then 1.1 for that coefficient, right? If I don't provide any number when I call that function, just provide x and y, it is going to work. Why? Because for that coefficient, it has a default number of 1. And that's why we call that parameter, that input argument, we call it a default parameter or default input argument. If I want to, though, I can provide a number. I can say 1.1, and then it is going to overwrite this and change it to 1.1. So this is how you provide a default parameter, just like C++, by providing a value for it. And so here, I'm just using that coefficient to change my radial distance, which is, of course, not mathematically true unless it's 1, but just for the sake of demonstration. And so here you see I'm raising x and y to the power 2, add them, take a square root, and that's r, and theta is the arctangent of y over x, math, and then math into degrees, okay? And that is going to give me theta, and then I return r and theta. So now in my code, here I'm gonna ask the user to give me x and y, okay? And I should actually add something. I should say separate by space, because here I'm using .split command. And as you learned in the first video on IO Basics, what this one does, it is asking the user to give the numbers separated by space. It's gonna split them into two numbers and then assign them to x and y using this for loop. So I'm saying for x in input, for any value in input, go ahead and before assign it to x and y, cast it to a float number, and then pass it to what? Pass it to this function. And then I can get the number. And here I use the default value coefficient 1 of 1, and that is going to return me what? The r and theta. So let's go ahead and run this first part. So give the x and y coordinates. So let's say what? Let's say 4 and 4, right? And you see the distance is 4 times the square root 2, and the angle is, of course, 45 degrees as it is expected, right? So you see it is working what? Just fine. Let me now change that coefficient to 1.1, which is, of course, going to make this number a little bit bigger. Not going to change the angle, but let's take a look. I run it again. And this time, again, I say 4 and 4. And as you can see, it has changed r now to 1.1 times that number, and the angle has not changed. So you see that's the use of what? The default parameter. And so you see it is working just fine, right? So I'm using this function in a test code and no worries. Now, one question. Here is my test code, right? And here is the function. You see the function is written before the test code. You might say, can I bring this test function under the text code? Can I bring it right down here? Like you do in MATLAB, right? In MATLAB, you start your script, and then at the bottom of the script, you have your functions. Can I bring my function at the bottom of the test code? Is that going to work, right? And for the sake of demonstration, I'm going to turn off the rest of the code, just work with this portion here, okay? So let's see if it works or not. So let's go ahead and run. And you see, apparently it is working, right? No, it's not. There we go. It says name my car tuple is not defined, right? Because here I'm saying, hey, give me this value, and then it looks up and say, okay, where is my car tuple? It cannot find it. So if I have to use a function in a test code, the function has to be declared above the test code, just like C++. Remember, in C++, you start your functions before the main loop, and that's the exact same thing here. Your functions should be defined above the what? Above the main loop, as you just saw. This way they are working. If you define them below like MATLAB, they are not. So be very careful about what you're doing. Okay, now let's look at some other things about functions. So here I have another function that is a void function, and it's called isPrime. I pass it a number, and it tells me in the message on the screen whether the number is prime or not. How? Just like my C++ code, it starts a flag of true, and true means the number is prime, and then goes and checks all of the numbers in a range from 2 to the square root of z, and I'm using ceiling of that, so I can use the integer that is a little bit bigger than the square root, because most of the time the square root is not an integer, it's a decimal. And if I divide I by all of these numbers, and the division, the modulus, the percentage is 0, means z is divisible by any of those numbers, then I change my flag to false, which means my number is what? Not prime. And note that I do not need to divide z by all of the integers from 2 to z. As long as I go to the square root of z, that's enough. You don't need to keep this going all the way up to z. Just to the square root of z is enough. If it's not prime, it's going to show itself. And if it doesn't, then it is a prime number. So you see, and I'm using an if-else statement based on the flag value to show if it's a prime or not a prime. Now, here is the interesting thing. One, this program does not return any value. It just shows a message. So it's really, in terms of C++ terms that we learned, this is a void program, a function. The other interesting thing is this function is using another function called mySquareRoot. And this is the same as the square root, but I'm using it as a utility function. So my function is using another function as a utility function, and that utility function is providing the square root value here. Now, why did I do it this way? Because I wanted to show you that one function can use another function, right? And this relation is called basically the calling and the utility function, right? Or the primary and the secondary function. So this is like the main contractor, and these are like subcontractors basically in terms of construction. And so the question I have is, first of all, it works. Let's check whether it works or not. So let me provide some numbers here, and then here is the second part. It is asking for a number to check if it's prime or not, and I say, let's say 43, and you see it says it's a prime number. Now the question is this. Remember, we checked whether this function should be above or below the test code. How about the utility function? Right now, the utility function is above my calling function. So when I get to the mySquared, it's already defined above it, and there is no worries. So what if I bring this utility function below this primary function? If I bring it here, is that going to cause any problem? Just like it did for the test code. If I bring my utility function below, is that going to cause a problem? Well, let's take a look. Let's test it. So here we go. So 3 and 3, and then what? 97. You see, it didn't cause any problem. It says number is prime. You see? So it did not care whether this utility function that I need here is not defined above. If it's defined already below it, it is still going to work. And that is some important lesson I want you to take out of this lecture, that the utility function can be defined before or after the following function. But in general, I would add something for you here, that a function used in test code has to be defined before the test code. Okay, otherwise it is not going to work. So if it's the relation between a test code and a function, definitely you have to have it ahead of time. If it's just between two functions, one primary, one secondary, then there is no worries. Okay, wherever you define it above or below, it is going to what? It is going to work, like this case here, right? You see, there is absolutely no problem. But if I bring this utility function down here after I called it, right? So here I'm calling is prime, and I'm bringing this definition of utility for this is prime below even this place that is calling it. Is that still gonna work? Because when I put it down here, it was right after it. What if I put it even after that area in the code that is calling it? Can I do that? Can I still do that? Let me check this last part with you. So 3 and 3, it works, and then what? 67. You see, now it doesn't. Now it doesn't, because you put it so far down that it's not working. Okay, I did it so far down that it is not going to work. Okay, it's not working. And just out of curiosity, if I put it right before it, like, can I put it in the middle of my text code, but before this is prime? Is this still gonna work? Let's take a look at this one. So I'm looking at you in all sorts of scenarios, whether something is gonna fail or not. 57. You see, this is still working. Right? So whether it's among the blocks of functions or in the text code, as long as the utility function is above the line that is using its primary function, I'm good to go. Right? So it doesn't necessarily, a utility function does not need to necessarily be defined all the way up here, but it's better for the readability of the code to be written right above or below, and professionally I would say it's better to be written above it instead of below it. But I'm just trying to show you all scenarios. So let me add that for you here, that utility function can be defined before or after the calling function, as long as it is placed above the code, the line of test code that is calling its primary function. You see, that's the important part. Other than that, everything is good and it is working. So here I showed you different scenarios: a returning function, a non-returning function, one function calling another function, and the default parameters. So hopefully this video is useful to you, and I'll see you in my next lecture. Thank you.